Okay, so loss function, if you see, loss function is if you have an estimation problem, so what are the components of a estimation problem? You have a data, right, which is x1, x2, is at your disposal. You have a family of distributions because we are talking about only parametric family of distributions, f theta theta, family of joint PDFs, you can see. It is a joint PDF of x1, x2, x. Then you have a random sample. Then it is a product of marginals of x1, xn, and so on. Now, psi theta is an estimate. This is something which you are interested in estimating because theta is unknown. So your psi theta is also unknown to you. So you are interested in estimating psi theta. Suddenly, since you are estimating based on just x1, x2, xn, which is just a part of a population, which is a representative of a population, it is not the population itself, right? It is only a one part of a population because you have taken a sample from this. So suddenly there will be some error in your estimate, right? So that is measured through the loss. So L theta D, let me say it has two quantities. It will depend on what is the true value of the parameter is. And D is the what action you are taking to estimate, right? It could be a sample mean, it could be. So it is a loss in estimating. Psi theta by D. If you're estimating it by D, this is the loss. Then you have a concept of a risk function because your loss would depend on what your sample has been observed. And different occasions you'll observe a different sample. And beforehand, you don't know what sample you are going to observe. So it makes sense to talk about the average loss, which we call as a risk function. P theta, L theta, delta x. Because distribution of x depends on theta, you have averaged out only x's. So theta would still remain. This is a function of theta. So this is the risk function. Now, one can think of various kinds of loss, right? Various kinds of loss. First is absolute error. This is one particular kind of loss. So depending on what you are considering, this can be considered as if psi is a real value. It is the distance of psi theta from D. So if this distance is large, you have more loss. And loss would be zero if you estimate D is exactly same as psi theta. Second kind of a loss function could be squared error. L theta D is psi theta minus D whole square. Right? In general, one can talk about L theta D to be convex in D. You don't assume particular form. Say you take any loss function which is convex in D. It would be absolute error, it will be squared error. All of these loss functions are convex in D. Convex in D, convex function of D for every theta belonging to. For example, modulus of psi theta minus D, if you look at this loss functions looks like this. It's minimum it at psi theta. So, and is as a function of D, right? Sorry, D is over here, and this is theta D. We see it is a convex function because you take any two line joining here, they always lie above. Squared error, similarly, it is like this, minimum at psi theta. This is also convex that you can easily see by taking the double derivative or just join any 2 points, they lie above it. So squared error is a particular type of a loss function, right? Is that clear? Does that clarify to you?
Yes, sir. Yes, sir. Thank you, sir.
Okay.
Sir,
Anything
can you
else?
please sir, assignment number 6, question number 4.
What is the fourth problem? I don't have assignment with me. If you read it for me, it would be easier for me. Can you read the assignment?
Sir, I'm reading.
Yeah. This assignment, which was problem 2? Assignment?
So problem number 4, assignment 6.
Assignment 6. Just read it for me. What is that says?
So let x1, x2, xn be a random sample from PDF.
Right.
Alpha x to the power alpha minus 1 by theta to the power
Just
alpha.
1 second. Alpha into?
X to the power alpha minus 1 by
By-
theta to the power alpha.
Okay. So there's a PDF from this. Okay. Nice.
X in 0 to theta.
Right.
0 otherwise.
Right.
Alpha is known.
Alpha is
Xi,
greater than 0,
alpha
right?
is known. Yes, sir. Alpha is known positive constant.
No, right. Okay.
So xi is a function from 0 to infinity to r. It is given that limit theta tends to 0, theta to the power n
Limit
alpha.
theta going to infinity, limit theta going to 0, right?
Yes, sir.
Of-
Theta going to 0.
Ah,
Theta to the power n alpha into psi theta equals to c.
is psi, right?
Yes, sir.
Theta power n alpha into psi theta is c, right?
Yes, sir.
Okay.
Non-zero constant c.
It is
We have to prove that UMV of psi theta does not exist.
UMVE does not exist. First, I suppose UMVE exists, right? Then I'll show that I get a contradiction. Suppose that UMVE exists. So in fact, UMVE exists, first condition is it should be unbiased, right? Then expected value of delta x is psi theta. Right? Now, if UMVE exists, there will exist a UMVE based on minimal sufficient statistic. Then there exists a UMVE based on minimal sufficient statistics. Let me call this as T. What is the minimal sufficient statistic in this case? Can you tell me what is the minimal sufficient statistic?
So Xn, another statistic.
Maximum, right? So then there exists based on why? Because there was a delta, so you can take an expected value of delta given T. That is also unbiased, right? So if there was an unbiased estimator, there will exist an unbiased estimator based on minimal sufficient statistic. That is what I take expected value delta given T. It is a proper estimate. Okay, so I need to show that there exists a UMV. Let me call this as delta star based on unit. So expected value of delta star T, that means would be same as psi theta for every theta greater than 0. What does that mean? This means density of psi theta would be how much? 0 to theta delta star T. And then density of, let us see what is the density of FT. It is, yeah. Do you remember what is the density?
So n factorial divided by n minus 1
Right.
factorial.
So it would be n alpha. You can see x to power n alpha minus 1, right? Theta to power n alpha. Is that okay? Or you want me to derive this? Is this okay, this PDF?
Yes, I understood.
Yeah. So that means this into n alpha, x to power n alpha minus 1 by theta to power n alpha, d alpha should be same as psi theta for every theta greater than 0. Is that okay? That means n alpha into 0 to theta delta star x x to power n alpha minus 1 dx same as theta to power n alpha into psi theta for every theta greater than 0. Right? What does that mean? If this is happening for every theta greater than 0, it should happen in limit also. So that means limit theta going to 0 of n alpha 0 to delta star x to power n alpha minus 1 dx same as limit alpha going to 0 theta to power n alpha psi theta, which I am calling this c. What is the limit on the left hand side?
That should be 0.
0. So that means you get 0 is equal to c. But your c is given to be non-zero. So you get a contradiction. That means whatever you assumed was not correct. That means the UMB does not exist. Does that clarify?
Yes.
Okay. Anything else?
Sir?
Yeah.
Yes, sir, just a clarification, like for showing ancillary statistics,
Right.
do we first, I mean, like identify if that distribution is a local location family or a scale
Yeah,
family?
that would be very, that makes life very simple, right?
Yeah, yes, sir. And then like if it is a location family, then we show that V of x1, x2, xn is equals V of x1 plus c, x2 plus c.
That is good
For
enough
some c.
for
and-
every C. Then it would be ancillary. Yeah.
Okay, and then using that we can prove that suppose x1 minus xn is also ancillary like this.
Right. So then if something is ancillary, then you can show that it will be independent of the complete sufficient sets. Is that okay?
Yes, sir.
You want me to go do some example? For example, let us look at x1, x2, xn is IID. Let us say uniform, right? Uniform theta minus 1 to theta plus 1. Its density, you know, is uniform theta 1 is 1 by 2. Indicate that x lies in theta minus 1 to theta. In fact, here you will try to look at for the maximum and minimum. That is what would be required. So let me write down because complete sufficient statistic in this case would be minimum and maximum, right? So let me take a better example so that I can clarify things much better. So let us say x1, x2, xn is IID with PDF. F theta x e to power minus x minus. Now, in this case, you know that T1, which is x1, is complete sufficient, right? So we like to see anything which is independent of, we like to see what is ancillary. So any statistics of the type V of x says that V of x1 plus c, xn plus c, that is same as V of x1, x2, xn for every c, that would be ancillary, right? Examples of such statistics could be T1, which is, let us say, summation I is equal to 1 to n, xi minus x bar whole square, right? Because if you add c, that c gets added in x bar, c gets cancelled, and you remain the same. So it is ancillary. Is that okay?
Yes, sir. Yes, sir.
Another statistics could be summation I is equal to 1 to n xi minus. Here, if you add c into everything, xi plus c becomes. If you add some c in everything, then minimum also gets added by c, right? Minimum of x1 plus c, minimum of x2 plus c, minimum of xn plus c is same as minimum of x1, x2, x. So that again, c would get cancelled and you will get as minimum of x1, x2, x. Here c gets cancelled again, you get c.
Sir, here we can just show that after adding c to all the terms to the term, the whole statistic remains the same, and hence we can say that it is.
Yeah, right. So this satisfies V of x1. So you can say that this satisfies V of x1 plus c, T of x1 plus c, T of xn plus c. For example, in the case of T2, you write down T2 of x1 plus c, x1 plus c is same as T2 of n for every c. So it is LCM. That is good.
Yes, sir.
Okay. Yeah. Any other doubt? Any one of you have?
Sir, from the lecture number 12,
Right.
can you please share the screen?
Me to share the screen. Let me see. First, that was module 4, right? I guess
Yes, sir.
module 4. See where is. So which page number is that? Can you? It was about what? Can you see the page number? Then it will be easier for me. You remember the page number? Hello? Can you hear me?
Yes, sir. So there was a result like delta and delta star, two randomized estimator. One is based on
Right.
sufficient statistics.
Right.
The risk would be the same.
Risk would be the same, right? Yeah. Yeah. You want me to explain that?
Yes, sir.
Okay.
In the
So
proof
let's-
part.
Oh, the proof part? Yeah. So proof part, let me see. This is a Lehman-Seffet theorem. For that, no, it is not in unbiased. That is a module 3, right? It looks like. Yeah, so that would be module 3, not here. See. Module 3. It's in randomized estimator we talked about. Yeah. So stop sharing. And then let me, what is the chat? Let me see. Can you see the screen? Can you see the screen now?
Sir, it's visible.
It's visible, right? So this is the result, right? It says that T be a let T be a sufficient statistics and delta X be any randomized estimator. It says that T be a sufficient statistics and delta be a randomized estimator. Then there exists an estimator delta star, which again could be randomized based on the sufficient statistics T, such that the given estimator and that estimator delta star, which is based on the sufficient statistic, would have the same risk. So it says is what you do is, because every randomized estimator has a probability distribution associated with it. It has a probability mass function or a probability density function. So what it says is you construct a new probability density function, which is the expected value of the old probability density function given T is equal to T. Right? So this is same as expected value of P of X old of A. A is the quantity with respect to you have to take expectation because here X is fixed, given T is equal to, that is what it. Take the expectation of the density with respect to distribution of X given T is equal to T. Now one can see that this is a proper estimator because for it to be a proper estimator, it should total integral should be 1.
So
If
why
we
is
integ-
that so?
Yeah, so if you integrate T star A, PT star A, TA, right? It would be integral over double integral Px A and then Fx given T is equal to T dx by theta. Is that okay? Double integral. Now, this is joint distribution of A and X given T is equal to T. Because this expectation would be that's the joint density of X and A, right? Because this is X given T is equal to T, X, and this is dx equal to theta. So this has to be 1, right? Because for every A, now A has been integrated out, right? Over here. Now once, so I can interchange the sign, this integral sign. So now here it was with respect to A, and this was with respect to X, right? And it took the expectation because here it was with respect to PT star A would be with respect to, A, sorry. Yeah, so A is outside, and then PT star A is PXA given T. Now I interchange the sign of integrals. It becomes P respect to X, and then integral over A, PX A, PA, Fx when T is equal to T, X dx. But PXA is a PDF for every fixed X. For every fixed X, this has to integrate out to 1. So this same as integral over T, F of X given T, X given T dx. But this is also a PDF with respect to conditional distribution of X given T. So this also would integrate out to V1. Is that okay?
Yes,
So
sir.
this is a proper PDF. So it is a proper PDF. So it corresponds to a randomized estimator because it is for every fixed T. For every fixed T means for every fixed X. So let corresponding thing be delta. Then what is the loss function associated with this loss function, with this estimator, PT star A? That is same as expected value of, if you want to write down in terms of expected value, so this is same as expected value of L theta A, and whatever that density is, PT star, right? This function is expectation of respect to distribution of X, right? Which is expected value of this quantity, right? So this is same as expected value of this is X is this is respect to A. This expectation is respect to A. L theta A PT star A. But what is PT star A? PT star A we have already seen above. That is further expectation of Px given T is equal to T. So this is E theta, EA, L theta A. This is same as expected value of Px A given T is equal to T. Now these two expectations, expected value and this is expected value of X given T is equal to T. So it becomes a joint expectation, right? And that is how you get it over here. It becomes a joint expectation, which is same as R theta delta. Does that clarify to you? Or?
Okay, sir.
Yeah, it is. See, what is happening is once you have taken this double expectation, this expectation was with respect to X given theta. This is X given T. So when you combine the two, it becomes with respect to the joint distribution of X and T given. It just becomes expectation with respect to X given theta only, right? Because So this becomes expected value of L theta A, and this is just expectation of PXA. And what is this? This is nothing but M theta delta, right? Because delta corresponds to PXA, and which is same as R. Just it is matter of writing down expectation as a matter of a conditional expectation. That's all. Because you can go backward. R theta delta was expected value of M theta delta, right? Which is same as expected value of L theta A into PXA, right? That is what it says. Now I write down this expectation as expectation of a conditional expectation. So go backwards, your expectation has been written as expectation of a conditional expectation. And then you finally go back to PT star, right? So everything is just based on the fact that expectation is same as expectation of a conditional expectation. And your M delta star has been obtained from delta, which is corresponding to PXA, through the conditional distribution of X given T. That's all. So it is expected value of PXA given T is equal to T. When you take one more expectation, conditional expectation of a conditional expectation becomes expectation, which gives you R theta, L theta, yeah, R theta delta. Is that clear?
Yes, sir.
Okay. So you write it down of your own. The fact which is being used over here is very simple. Expectation is same as expectation of a conditional expectation. So when you take R theta delta, you're talking about only expectation with respect to X. Now, when you talk about expectation with, for example, let us look at R theta delta. Right? R theta delta. What is that? There are two expectations in this. One expectation is at the randomization level, and the second is with respect to X. So the second is with respect to X, that means with respect to theta. This is with respect to A of L theta A, right? Into Px. So the way I was doing better, because there would be two loss functions over here. There are two randomizations. So I can so if you see your definition, I say that it is two-stage randomization. So this is same as expected value of M theta delta. And what is M theta delta? It is the expectation of a randomization at the first level, which is equal to A of L theta A. Is that okay? This is what it is. So your R theta delta, this is equal to theta, but to distribution of X. So this is same as expected value of L theta delta X, which is same as integral over, this is vector distribution of X, this is vector distribution of A, L theta A, then PXA, because that is what the density of the action is, corresponding to the estimated delta, and then density of X given theta. So let me call this as F theta X, joint density. Now, this joint density of F theta X can be written as, you can integrate, so I can write down triple integral F theta A PXA. Now this can be written as F of X given T into FTT, right? Because here it is a joint density of X and T integrates out, so only X is left, right? So that is what it happens. Now, whatever is there, I can integrate one of them with this. So it becomes L theta A integral over PXA. I interchange the pxa, and then f of x given t, ft. And this is px star a, right? That is what is happening. Conditional expectation is being written as a conditional expectation. Expectation has been written as a expectation of a conditional expectation. Okay, just try to work it out of your own, be very clear. Yeah, anything else anybody has?
Sir?
Yeah,
Sir, I'm having some problem finding the minima sufficient statistic from a PDF. Sir, can I read the PDF?
yeah, tell me.
Sir, it is 2 by theta square multiplied by theta minus x with indicator function 0 to 0 less than x less than theta.
Just let me. I'm trying to. Okay, so yeah, so let me just use the whiteboard again. Okay, let me, yeah, so what is your, what is the PDF?
Sir, it's 2 by theta square.
X1, X2, Xn are IID, right?
Yes, sir.
X1, X2, Xn are IID. Yeah, the PDF f theta x, which is same as
2 by theta square
2 by theta square.
multiplied by theta minus x.
How much?
Theta minus x.
Theta minus x, okay.
An indicator function of 0 less than x less than theta.
0 less than x. Right. So what you have to see is there would be, for this to be minimal sufficient statistic, for any two sample points, f theta x should, by f theta y should be independent of theta if and only if x is same as y, right? So let me call for sample points x and y. Let me call joint density of g theta. So this is a individual density. The joint density, let me denote by f theta x by g theta y. That would be how much? Product I is equal to 1 to n 2 by theta square, theta minus xi, indicator 0 less than xi less than theta, divided by product I is equal to 1 to n 2 by theta square, theta minus yi, indicator 0 less than yi. How much that becomes? Let us look at 2 by theta square gets cancelled. So theta minus xi I can write down separately. And then product indicator xi greater than theta. Indicator xi greater than theta is a two parts. That means xi should be greater than theta, greater than 0 as well as, so one I write down as it is product. So each of them should have to be greater than 0. So indicator xi, because I want to separate out the terms of x's from the terms of theta. So this doesn't involve theta because each xi is greater than 0, which is equivalent to saying that indicator xi is greater. Okay, then yeah.
Sir, here can't we write the xn is less than theta indicator?
I'm asking that second part I have to take care of now. The second part will say that because I have to take this, there are two inequalities over here. One is saying that each xi should be greater than 0, which gives me product I is equal to 1 to n xi greater than 0, which you can write down as a minimum also. It doesn't matter, any term which is depending on x doesn't bother me. The only terms which where theta and x are intermixed, they are the only terms where I have to be squeezing the data as much as possible. So here each xi is less than theta is equivalent to saying that xn is less than theta, right? So I have taken, so this whole thing is equivalent to writing down like this. Okay. This 2 by theta square is gone. Product I is equal to 1 n theta minus yi. Product I is equal to 1 n, indicator 0, indicator that is theta. Now note that here all xi's are coming, so I can write down this in terms of our order statistics itself, because all xi's are, because I want to squeeze as much as possible, theta minus xi. indicator. In fact, there's no need to write down indicator xi greater than 0 because x is a sample point. So this will always hold, right? But you can write it down, doesn't matter. Product indicator xi greater than 0. Indicator xn less than theta. Product I is equal to n theta minus product I is equal to n indicator y 0 indicator less than theta. Is that okay? Now this is independent of theta of n. Can you tell me? If and only if. These xi's have to be same because they are turning out to be the roots of an equation, right? Because is that okay? So this is equivalent to saying this is if and only if xi is same as y. Each xi has to be same as y, which of course takes care of the fact that xn also has to be same as y. So tx is x1, x2, xn is minimal sufficient. Because I'm not able to further separate out terms of xi's here. Is that okay? Want to do it much more elaborately? You can see that this is independent of theta. What does that mean? This quantity, this ratio has to be same as kxy for every xi greater than 0, yi greater than 0, xn less than theta, and y is less than theta. So that means product I is equal to 1 to n, theta minus xi is same as product k times xy because it does not depend on theta. So it means this ratio is same as some k times which only depends on x and y. Product I is equal to 1 to n, theta minus. If you want, you can write down here these indicators also. Indicator xn less than theta. Indicator. First, you can show that xn has to be same as y, right? Right. So first of all, note that this k has to be n. K has to be 1 because here left hand side is a polynomial in theta of degree n. Right hand side is a polynomial of degree n in theta. So the coefficients have to match. So this k has to be 1. Now you have done that. Now you prove that xn is same as yn. Now if xn is not same as yn, then what happens? In fact, for theta less than, for minimum of xn and yn, for maximum of xn and yn less than theta. So all theta bigger than this, you again have a two polynomials matching. But a polynomial can have at the most n roots. So if they match, that means coefficients have to be matching. But the coefficients have to be matched, that means each xi has to be same as y. That is the whole. Does that clarify?
Sir, can you repeat the last part once?
So you see what is happening is left hand side is a polynomial, right? In theta, right? Whose roots are x1, x2, xn, right?
Yes, sir.
Kxy I have already shown has to be 1 because right hand side is a polynomial in theta, left hand side is a polynomial in theta. So coefficients have to match. So theta to power n and theta to power n coefficient would match. So kxy has to be 1, right? So kxy is 1. Now what you have got product theta minus xi and product theta minus yi. These two polynomials are matching, right? Over certain set. What would be that set? Maximum of theta bigger than maximum of xn and yn. Because this is happening for theta greater than xn. This is happening for theta bigger than yn. So for theta bigger than maximum of x and yn, both would happen. So what you get is product I is equal to 1 to n, theta minus xi is same as product I is equal to 1 to n, theta minus yi, or all theta bigger than maximum of xn and yn, right? Because this expression holds for theta bigger than xn, this holds for theta bigger than y. Now what you have? So what it says is you have an interval, so which is basically this to infinity, right? So you have lot many values of theta, which are for which a polynomial on left hand side matches with the polynomial of right hand side. And there is a standard result which follows from the result that a polynomial of degree n can have at most n roots. So that means when I take the difference of these two polynomials, that is again a polynomial, it can have at the most n roots, but it is saying it is matching for all theta bigger than maximum of x and y and to infinity. So that means they are matching for infinitely many thetas. But a polynomial can have at the most n roots. So this cannot happen. If this has to happen, your polynomial has to be 0 throughout. Right? That means the roots have to be same. The two polynomials have to be the same. And because they can cancel and then the two polynomials have to be same, that means their roots have to be same. That means xi is same as. Is that okay?
Okay, sir.
Yeah. Because the idea is the idea which is being used over here is if there are two polynomials, they are matching on an interval, then their coefficients have to be the same. Not only that, their roots have to be the same. Right? If two polynomials are matching on an interval, you see, let us look at this. I'm saying, let's try to see. P1 theta is a one polynomial of degree n. And P2 theta is a polynomial of degree m. M and n I do not know. I am saying P1 theta is same as P2 theta for every theta in an interval, right? A to B, let us say. In our case, it was maximum x and y and to infinity. What does that mean? This means P1 theta minus P2 theta has to be 0 for every theta belonging to AB. But if P1 is a polynomial, P2 is a polynomial, P1 minus P2 is also a polynomial. So it is saying you have a polynomial which is 0 for every theta belonging to AB. That means it has infinitely many roots because it is becoming 0 for infinitely many thetas in the interval A to B, because interval A to B contains infinitely many thetas. So it is saying a polynomial has infinitely many roots, but you know that a polynomial of degree n can have at the most n roots. So it will be some polynomial of degree n or m, depending on which one is bigger. But whatever it may be a polynomial of finite degree. It cannot have infinite roots. If it has infinite roots, then that means the two polynomials have to be same. That means P1 theta has to be same as P2 theta. So this implies that P1 theta has to be same as P2 theta. The polynomials are same, their roots would be same, right? Because they put, that is what is exactly being done over here in the last page, if you see. I got this polynomial is same as this polynomial in an interval from maximum x and y and to infinity. If that happens, then I know that from the discussion I had just, the roots have to be same. So that means x1, x2, xn, and y1, y2, yn as a set be the same. So that means smallest over here should be same as smallest over here. Smallest over here is x1, smallest over here is y1. So xi is same as y. Is that okay? Now note that it would be clear. You may argue that, see, I could have used the same argument even without writing down these as order statistics. I could have written only theta minus x size, theta minus x size, theta minus x size. Perfectly fine. Then what you would have gotten is as a set x1, x2, xn same as y1, y2, yn as a set, because I'm saying that roots of the two polynomials would be the same. So even if it was without order, theta x size, I would have got roots of this polynomial would be same as root of this polynomial. Roots of these polynomials are x1, x2, xn. So as a set, x1, x2, xn would be same as y1. But as a set, if they are same, so smallest here has to be same as smallest over here. I cannot say that x1 may not be same as y1. But smallest here would be same as smallest over here. That gives me x1 is equal to y1. Second smallest over here would be same as second smallest over here. x2 is equal to y2 and so on. Does that clarify to you now?
Yes, sir.
Okay. Anything else?
Sir, for this problem only, sir, it was said that we needed to find the method of moments estimator and the MLE.
Right.
And then they asked that if they are functions of a minimal sufficient statistic.
Right,
So sir, the method of moments estimator we will get in terms of the mean of
Right.
x1, x2, xn,
right.
and sir, the MLE would be x order n.
No. I think in this case, only two observations must be given, right?
Yes, sir.
That I did last time in the lecture. If you ask, you want me to do it again? Last time I did it. I think last lecture somebody asked this. You
Sir,
want me to-
actually,
Yeah,
sir,
tell
the
me.
MLE would be different.
Yeah. It will come because excise will also come, na? Just see over here, na? I just see the last lecture. I have a last tutorial. I posted that in the. I provided a solution over there. In the video of our last tutorial.
Okay, sir.
This is your. Huh?
Then I'll check, sir.
Yeah, so this is the likelihood function you are getting, right? Theta minus x1, theta minus x2. And what was the below that? It is some constant, right? You don't have to bother about that. And this is for xn less than theta, right? Something of this type?
Yes, sir.
Less than theta, x2 less than theta. So I take the log of this, log of theta minus x1, theta minus x2. And then I see that because x1, x2, you see, it cannot be xn, right? Because it was happening in the uniform case because your likelihood function was a decreasing function of a theta. Here I do not know whether it is a decreasing function of a theta or not, right? So I have to see what it is there, right? So I just try to see what is its behavior. So if you don't want to do this way, you can do this way also. Lx theta I can also write down. It's better to write down in terms of order statistics, theta minus x1, theta minus x2. And this is for the situation when theta is bigger than x2, right? So there is a theta over here. There is x1 over here. So this is what Lx theta is only, right? This was the density, right? Theta minus x1 by theta minus x2. Let me just check.
Yes, sir. Another
And
constant term.
theta square was also there, right? Theta minus x1, theta minus. So let me write. So it was 4 and theta square, so that becomes theta to the power 4, right? This is what it becomes.
Yes, sir.
So it becomes this to power theta to the power 4, right? So I think to see the behavior, I just can consider log of Lx theta, which is minus 4 log theta. That's log of theta x1 plus log of x2. I study its behavior with respect to theta, which is minus 4 by theta plus 1 upon theta minus x1 plus 1 upon theta minus x2. And then I see its behavior. So let's see the tutorial the video of the last tutorial. I've completely solved this problem over there. Is that okay?
Okay, sir. So here we will not consider the indicator term like we used.
No, it will be there because your likelihood function is depending on theta. So this would be this for theta bigger than x2. So likelihood, so it is, we'll consider this. So your likelihood function depends on what x2 is. So what would happen is with this, you will obtain that, you'll get a polynomial, and you will get that the roots of that polynomial would be, so this x2 may be in between. So there'll be a theta 1 hat and theta 2 hat, which would be basically you will get a polynomial of this because you'll have to put this equal to 0. So you'll get, if you want to see its behavior, what would be its behavior? So theta minus x1 and theta minus x2 will come in the denominator. This becomes theta into theta minus x2 plus theta into theta minus x1. And then with this minus 4 times theta minus x1, theta minus x2. And you try to see what is its behavior. So that will turn out in terms of a root of equation. Now your function is like this, right? So you'll have to see the behavior of the function is after theta bigger than x2, right? So that
Yes, sir.
that indicator will come into the picture because you have to see
Okay,
behavior
sir.
only for theta greater than x2. that okay?
Yes, sir. Yes.
And then you can get a maximum or minimum.
Why are we taking log over here for the likelihood function? So we could have done simply without taking the log.
That also you can do. I thought with taking log it would be easier. You can do it without that also. You can take the derivative, theta to the power 8. Then you have to take the derivative of these two minus theta to the power 4, and then so you can write down this. That way also you can do. There's no compulsion. You can do it by whatever suits you. This theta to the power 4 minus x1 plus x2. Theta plus x1 x2. Take the derivative, see the behavior. That way also you can do. There is no issue. Is that okay? Right? Any other question anybody has?
So for the case of the question where x has a PDF given by alpha x to the power alpha minus 1 over theta to the power alpha type. So there we have so for assignment 6, question number 4, second part, we were given that there exists a function psi theta which is U estimable. We have to find the UMV of that. So how do we do that in general case?
The first part I have done that if that limit is C, then the UMV does not exist, right?
Yes.
That I have done, right? That you already know, right? That I did in the beginning of today's lecture. What you are saying, if x1, x2, xn are IID, yeah? Then what was the density? F theta x is alpha x to power alpha minus 1 by theta to power alpha, or 0 less than x less than theta, right? And psi is some U estimable function. Then what is the question? You have to find the expected value also. So suppose
we have to find the UMV of psi theta.
Psi theta. So first of all, UMV has to be based on a complete sufficient statistic xn. Is that okay? What is the density of FTT? So this would be same as I think n alpha t to power n alpha minus 1 theta to power n alpha 0 less than t less than theta. Is that clear? That t is equal to xn has this density. Okay. So what I have to do? I have to find a delta. If I can find a delta, says that expected value of delta t is same as psi theta, I am done. Is that okay? Because by Lehmann-Seffet theorem says any function of complete sufficient statistic is UMV for its expectation. So delta is a function of a complete sufficient statistic. So it will be UMV of its expectation, which is psi theta. Is that okay?
Yes.
So, okay, so I solve this. This becomes 0 to theta n alpha t to power n alpha minus 1 theta to power n alpha dt minus psi theta. That means n alpha 0 to theta. Sorry, delta t should be there, right? Delta t to power n alpha minus 1 dt same as theta to power n alpha psi theta. First thing is, the first part you can take by taking theta, limit theta going to 0. Because if it is happening for every theta greater than 0, it should happen in the limit also. So that means limit theta going to 0 of this quantity, same as limit theta going to 0 of theta to power n alpha psi theta. But this is given to be C. What is the limit of this? This is 0. So that means 0 has to be same as C. So that means if this limit is different from 0, your UMV will not exist, right? That is the first part. The second part says if UMV exists, then this has to be satisfied, right? This is satisfied if and only if, at least if this is satisfied, I take the derivative both the sides. Right? I take the derivative both the sides. That should happen. That means delta theta to power n alpha minus 1 is same as derivative of this, which becomes n alpha theta to power n alpha minus 1 psi theta plus theta to power n alpha psi prime theta. What does that mean? That means your delta theta has to be same as what is happening? N alpha, sorry, yeah, N alpha into theta. So N alpha minus 1 alpha, so N alpha psi theta plus theta power N alpha divided by theta power N minus alpha, so that is becomes 1 by theta psi prime theta. So this is the UMV of psi theta, right? So your delta T, this since this is happening for every theta greater than 0, so that means your delta T has to be same as N alpha psi T plus 1 upon T. This is your estimate. Whatever psi may be given. Now you can choose different size and you can get the UMVs. Is that clear?
Yes.
Okay. Anything else anybody has?
So if we have UMV UE of a parameter theta, then
Right.
can we say that if we have delta x as the UMV UE of theta, then can we say that xi of delta of x will be the UMV UE of xi theta?
No, if you have,
I don't.
no, what
So
are you
if
saying?
we have,
Yeah.
so we have a parameter theta and its UMV UE is delta, then
So
sir,
you have
can we
a
say,
you have a parameter theta and its UMV is delta. Right. Yeah.
can we
Then
say that xi delta will be UMV UE of xi theta?
no,
I
that
don't
will
think-
not. That will not be. UMV doesn't happen that. It will change. Right. For example, in the normal theta 1 case, right? X bar is UMV of theta, right? But X bar square is not UMV of, in fact, it is not even unbiased. You see expected value of X bar square, what would be this variance of X bar, which is 1 by N, plus expected value of X bar whole square, theta square. So X bar square is not even unbiased, forget about being UMV. UMV would be expected value of X bar square minus 1 by N. So UMV of, this is for every theta, of X bar is theta, UMV of, sorry, UMV of theta is X bar, UMV of theta square is X bar square minus 1. Right? So what you say is not correct. Does that clarify your doubt?
Yes, sir, I was thinking the same way, but I did not have any explanation.
Yeah. So no, that is not correct. Any other doubt anybody has? Okay, if there are no doubts, anyway, we had a session of roughly an hour. So I can invite any quick question anybody has. Okay, if not, then I wish you all the best for tomorrow's exam. You can use whatever material you want to use tomorrow. Okay, that's all then. Shall I call off the meeting?
Yes, sir. Thank you, sir.
Okay. Have a great day.